My name is Emily Burns. I work at Netflix on Spinnaker. This is Rob Fletcher. He also works at Netflix on Spinnaker. Spinnaker is used at Netflix by almost everyone for almost all deployments. And one of the reasons it's so successful at Netflix is because we customize it. So our team, Delivery Engineering, provides customization, and so do some other Netflix teams that make up the general runtime platform. This customization makes things pretty sticky and makes Spinnaker pretty good for accomplishing workflows at Netflix. But even with this customization and work, we're seeing some problems. So when we first started Spinnaker 5 years ago, Spinnaker was a big change from the previous tooling and helped accomplish the workflows that people needed to in a much better way. So people might have had an application represented by this small square and a simple pipeline represented by this progress bar that kind of looks like a pipeline. And that was a pretty good workflow. And our users were probably cloud experts, and they wanted to control every single knob and dial. And they knew a lot about AWS, and that was great. We exposed a lot of AWS things. But over the past 5 years, things have changed a little bit. So Netflix has almost tripled the number of subscribers we have, and we've almost doubled the number of employees. And complexity and scale have increased in every area. So teams are bigger, teams are managing more services, they have to know more, they have to integrate with more, and that makes the picture look a little bit more like this. So maybe now you're on a team and all of you are managing 6 microservices and you have many unique pipelines, and we hear things like, it's hard to keep my similar apps up to date. So maybe each of your apps is deployed in several regions and has several environments. And let's say you want to make a change, like add another region or change instance size across all your applications. That's really error prone. You have to do a lot of manual operations in the UI, and you're probably going to mess something up. That's not really fun. We also hear questions like, what's the current best practice? People get the pipelines that existed as best practices when they generated their pipelines or when they initially created them, and that opinion is kind of frozen in time. So if you generated a pipeline that deployed in some way, you're not going to get automatically updated, and so you really have to figure out what are the new features and what you can use. People also wonder, why is this so complicated? And we see complication in several places. So first, maybe you're just doing something complicated. Maybe you have a bunch of shards, or you have one master pipeline to rule all your other pipelines, and you're using a lot of spell expressions. And so you might just have a complicated pipeline. We also see complication when you weren't the original owner of the pipeline, but you're now the maintainer, and you want to know why some decision was made. Like, is it necessary to scale my cluster down to 0 before I deploy my next version? Can things really not run at once? It might be hard for you to answer that question and know if it's a real reason or if that's just how someone else created the pipeline. When we look at these pipelines, we often ask a different question, like, what are you trying to do? It's really hard for us to understand where our users want to go and how we can help them when we don't know what the end state of their pipeline is. When we have a simple pipeline, it's pretty easy to understand where our users want to go. Maybe they start off with an artifact, and through several steps, they want to deploy to their test environment. That's pretty simple to understand. But we often see pipelines that look maybe a little bit more like this, and users that say things like, I'm just trying to figure out why my pipeline is failing right now. Or the person who made this pipeline left, and I don't know how to change it. I don't know what's safe to do. And mostly, our users are saying, I want things to be easier.
So currently, the concept of the pipeline is front and center in Spinnaker. That's the thing you deal with all the time. That's the thing you're thinking about. And this is fundamentally an imperative viewpoint. It's all about steps to get from A to B. We need to know more than that in order to understand what somebody is trying to achieve, we want to reframe this to think about intent. If we can understand the requirements for an artifact to be promoted through environments and get safely to production, we can guide people better in achieving that. So let's think about what this might look like in steps. This is a pretty standard deployment flow. So an AMI gets baked, we deploy it to a test environment, and later smoke tests happen, canaries happen, and ultimately we deploy to prod. A lot of teams have something logically the same, but organized differently. A lot of teams have something more complex than this, but this is pretty typical. And of course, the complexity is that often this is not just one pipeline, but it's a series of pipelines that follow on from each other. They're triggering each other, or they're using pipeline stages to call out to other pipelines. And it can, if one of these fails, it can be hard to notice something is wrong, and it can be hard to take the right corrective action to fix it. And it's also hard to see when you look at that executions tab in Spinnaker, it's often hard to see, well, which of these multiple pipelines belong together as one logical flow from commit to production. The information is there, but we don't organize the presentation in Spinnaker itself around that information. So it can be hard to trace that. And we want people to be able to speak to the tool the way they're thinking about things. We'd like to reframe things into thinking about intent and requirements. So we can reframe that same deployment flow as, well, my Debian always has to be baked into an AMI and then pushed into test, and the test environment should always have the latest version of the code. Before I go to production, the artifact has to have been smoke tested and canaried. So this is just a different way of looking at exactly the same thing. And if we as the Spinnaker team can understand what your intent is, we can do more to take responsibility for helping you get there. So obviously Spinnaker's 5 years old now, and we didn't expect some of this scale when we first started. You know, it was great for a lot of our users to go to a cluster view where they could see all of their regions and accounts at once. That was an enormous step up from Asgard or from the AWS console at the time. But there has been, as Emily pointed out, a whole lot of scale within the organization and within the use of Spinnaker since then. Netflix users don't always want to make all the decisions. You know, we used to have this assumption that everyone touching Spinnaker was going to be an expert in the cloud, an expert in security and scaling and everything, and that's just no longer a valid assumption. And often the Spinnaker team ourselves are not best placed to answer some of the questions, even though we're often the first line of support. People don't want to have to constantly update pipelines when recommendations change. You know, we run entire change campaigns around deprecating old libraries or trying to get people to migrate to new instance types, for example. And people increasingly want to be able to define similar configuration and infrastructure across multiple homogeneous regions or accounts or even apps. And you know, it's kind of ironic that we miss this because Spinnaker itself is like this. It's like a bunch of apps that all have extremely similar pipelines and extremely similar infrastructure. And people also want guidance in making decisions and choosing best practices. We have some incredible engineers at Netflix on centralized teams doing things like security and capacity planning. And for our engineers to be able to lean on that expertise in making their applications stand up in the best way possible, we can address what Dave Hahn was talking about in his keynote earlier, helping engineers build services that are fast, safe, and continuously deployed. So, one of the first things we hear quite often is that people want us to be able to store configuration as code. This has a number of advantages. It's super easy to review changes. It's easier to generate things from a base configuration, and those base configurations and templates are shareable. People also want help deploying things in the right way. The ability to share best practices, keep on top of updates to those best practices, and opt into experts making decisions about details so that they don't have to. Dave Hahn talked this morning about decoupling application development from operational expertise, and that's a key concept here. Now, managed pipeline templates addresses this in part, but it doesn't have that shift in viewpoint I was talking about from the imperative to the declarative, intent-based mindset. Another thing people are increasingly doing is defining similar config across homogeneous infrastructure. We have a team in Netflix called MEAN, which stands for Managed
Experience for
most of Edge, who are using MPT extensively to enable their sub-teams or the teams that they provide services for, to manage their applications in a very standardized way. And we want to integrate with them. We also have a huge amount of expansion on the studio side of Netflix recently, which brings a whole different set of applications to the table that are also trying to use Spinnaker. So to sum up where we want to go, we want to lift out important concepts for delivery, which means artifacts, environments, and how to promote between them. We want to pivot focus from imperative steps to a workflow to a view based on intent. Spinnaker, for example, already has a few standardized deployment strategies, but we can probably supercharge that approach and do more there, offer people more out-of-the-box options. And the Spinnaker team can then take some responsibility for helping people do the how part of how to deliver changes safely when they can express to us the intent they have or where they want to get to. And we also want to build on the plugin effort that some of our engineers on the Spinnaker team, like Rob Zenit, are doing some really interesting work on, and members of the community as well, so that we can abstract some of the decision-making involved in getting from, well, this is kind of how I want my app to look, to the fine-grained details of what that really means. Now, an obvious question might come up here. Why don't you just use some product that's already out in the community? So Kubernetes isn't used at Netflix. We have Titus, our own container cloud, which is optimized around tight integration with the Netflix ecosystem for permissions and stability and scale and operations and so on. So that's not really an option for us. But also, Kubernetes doesn't entirely address it's an infrastructure as code tool, but it doesn't address the delivery portion of what we want to achieve here. Cloud Foundation and Terraform are really designed for first-time setup. They're not optimized around zero downtime changes to existing infrastructure. Managed pipeline templates is really interesting, helps with sharing approaches and templates for defining pipelines, but it doesn't have that shift in viewpoint I was talking about. But we're really interested in seeing how we can use managed pipeline templates as kind of that supercharged deployment strategies or smoke test, canary strategies, verification strategies that I talked about a moment ago. So what are we doing?
Because we can't find what we need in an existing tool, we're building our own solution, which is a part of Spinnaker, which is all open source, as you might expect, and we're calling it Managed Delivery. We also love rainbows. So the first thing and the foundation of this is defining infrastructure as code for the platforms that Netflix uses. So this is AWS and Titus. And also allowing people to define delivery requirements as code. So not just the static environment, but how does your software package travel through your different environments and ultimately end up in production. Building on that, we want to add functionality to really improve the experience around sharing configs as best practice, updating them, and also safely rolling out those updates to users. So it's not really good enough to change your best practice and have it hit everyone all at once at the same time. That's not safe. We'd like to make that safer. And then the last thing is providing pluggable spots for other people to inject their opinions. So as Rob mentioned, we're not experts in everything. Our users aren't experts in everything. If they want, we want to allow our users to leverage the opinions of other experts. Of these three distinct chunks, the first one we've built, we're working on, we're testing. The second two chunks don't exist yet. If they're really interesting to you, maybe they would be helpful at your company. We'd love for help building these, building all of them, really. So keep that in mind. So more in detail about what we built. We've been talking about this for a while. Let's see what exists. So we built a new microservice called Keel. And Keel is the service that figures out what your desired state is, checks that against your current state, and also submits tasks to Orca to make changes. We've also built some basic UI support, and we have some great mocks and designs and vision around how this is going to be worked into Spinnaker UI and how we're going to build better views. So let's start with some definitions so we're all on the same page. We're talking about artifacts, and for us, that means a version software package that you deploy, and for Netflix, that's a Debian or a Docker container. We're talking about resources, and we're thinking of those like a piece of infrastructure that you'll be able to manage declaratively, and these are Spinnaker resources, so things like load balancers, security groups or firewall rules, and clusters. The current state and the desired state are a pair. So the current state is the actual state of the resource right now. It may exist, it may not exist. And the desired state is the state that you would like the resource to be in at all times. And then the spec, or the resource spec, this is the user-supplied definition of the resource, and it might contain abstractions or more human-readable language. It's not the fully detailed model that we use in CloudDriver or that AWS might use. So the first thing that we've built is declarative infrastructure for the platforms that Netflix uses. So we have support for EC2 security groups, load balancers, clusters, and Titus clusters. You'll notice Kubernetes is not on this list. If you're interested in helping us, again, talk to us. We'd be so excited about that. So what does this look like? Here's some shortened YAML for you to look at. This example is an EC2 cluster. You'll notice the format might look a little familiar. Kubernetes has great API design. And so we have metadata, and then we have the spec, which is all the details about the resource. You'll notice here that it has a moniker, it's a Spinnaker concept, and it has 2 locations in one account. Has some launch configuration information because it's an EC2 cluster, and it has some dependencies in words and not IDs. Once you have this resource spec that you've lovingly crafted, your YAML that you'll cherish, you can get it into Spinnaker in one of 2 ways. So you can either submit it straight to the API. If you have other tooling that you're building on top that generates things, you're mapping from your own configuration language, you can submit that directly to Spinnaker. You can also do a more GitOps flow. You can check your resource into Git. You can set up a trigger, like a Spinnaker pipeline that's triggered off Git, that will submit the resources, again, to the Spinnaker API. Keel, the microservice, is the source of truth for these resources. We're not pulling Git. We're not looking at that. We don't want the dependency there. So every time you make a change to your resource, if you store it in source control, you'll have to resubmit it to us. Keel is a part of the Spinnaker ecosystem, which means that requests go through Gate into Keel. Keel has its own database where it stores its configuration. And then Keel speaks to CloudDriver to get information about the current state. And it talks to Orca to make changes, and then Orca talks to CloudDriver. So all part of the familiar ecosystem, we're using Spinnaker concepts. So the heart of Keel is a resource monitoring loop. Keel will very frequently check the spec that you've submitted, this human-readable format, and it will get the current and the desired state. To do that, it talks to a resource handler. A resource handler exists for every type of resource, and it's responsible for doing the specific actions that pertain to that resource. So once Keel has the current and desired states, in a centralized place, we take a diff, and we figure out, is there a diff, is there not a diff? If there isn't, we don't have to do anything. We can check the resource again later. If there is a diff, we talk back to the resource handler, and we ask the resource handler to resolve the diff. So more about the specific resource handlers. They have 3 main jobs: get the current state, get the desired state, and reconcile any deltas. So you'll notice they're not responsible for when they should check things, and they're not responsible for figuring out if there's a diff. So if you're implementing a new resource handler to support a new resource, you don't have to worry about that centralized core logic. You just have to implement the current, desired, and resolving a delta. So the handler gets the resource spec, the human readable one, and translates that into the same model for both current and desired state, and then returns that back to the centralized Keel monitoring loop. When there is a delta, the resource handler gets the spec, but it also gets that difference that we've calculated, and the handler can take specific action for that. So say your cluster was supposed to have a high capacity, but your teammate didn't know and resized it down. The resource handler for the cluster will get that information, and it will know that it can just resize the cluster. It doesn't need to launch a new one. And it will return the task IDs.
OK, so that's infrastructure as code, which might look familiar to anyone who's using Kubernetes already. But we needed to build that to achieve some kind of parity on the platforms we're using, AWS and Titus. But let's think about the really interesting stuff, which is what we're building on top of this. And we have some concepts here, such as resolved desired state, opinionated desired state, delivery as code, and environments and promotion. So let's go through what that means. Resolving desired state enables us to use a bunch of smaller components to fill in the blanks in a spec. So we would like people to be able to define specs in fairly abstract ways where it's appropriate. Right now, there's a fairly small amount of abstraction, but we'd like, as we're building more and more of Keel out, we expect that level of abstraction to rise. So we want to get to a point where somebody can just define a cluster as, I want it to run this package, I want it to be deployed in these regions, it needs lots of memory, I'm not going to tell you the exact instance type, and it needs to connect to these load balancers and these security groups, and so on. We don't ever want people to have to deal with IDs of things. So for example, if you've got a cluster that spans multiple regions and it's connected to a load balancer, those load balancers may have the same name, and Spinnaker has certain assumptions around how things are expected to be consistent between different regions. But they will have different IDs in each region. We don't want people to have to worry about IDs of like VPCs or load balancers or accounts or anything like that. So we always deal with names. So the first thing that we need to resolve is like turning friendly names into localized region-specific IDs. But we can do more interesting things than that with resolution as well. We can, let's figure out, well, what kind, if you say you need a high memory instance type, but what does that mean in practice today based on the current recommendations from our capacity planning team? You say you want the latest version of this software package deployed. Well, let's figure out what the latest version is and which AMI has that and what the IDs of that AMI in every region are. And we can plug that into the launch configuration of the server groups we're going to create. So what resolution does is produce the fully hydrated, finely grained detail. And it can be like a many-to-one relationship in a way. So a cluster can can resolve to multiple server groups, one per region. And we can diff that whole group of things at once against reality, against the real current state, and decide whether it's a diff. And then we can be smart about taking actions only in the regions where a diff exists, or only taking actions based on the specifics of the nature of the diff. Like Emily mentioned earlier, we can resize, for example, instead of launching a new server group, if that's the appropriate action to take. Opinionated desired state builds on top of this, and this is where we kind of have the ability to plug in opinions from centralized and local centralized teams. So not all application owners are experts in the cloud. The Spinnaker team are also not experts in everything. You probably experience this at your own companies if you're trying to encourage people to use Spinnaker in the right way. So these are the kind of questions we see very often. What capacity constraints should I set? What region should I be in? What scaling policies will help me deal with my traffic variability? What instance type should I use? How should I configure security? That's something we deal with over and over again. And we want to build something that makes this easier for people. Let's consume those opinions in a pluggable way from the expert teams and resolve abstractions in the spec into fine-grained infrastructure details that people don't then need to concern themselves with too much. And these opinions crucially can change over time, either because your app changes or because the received wisdom about the best practice changes, or just because the landscape changes. For example, if Netflix goes into a new region, or if Amazon launches a new instance type family. We run change campaigns around things like that all the time, and we can eliminate a class of that just by automatically updating people. Right now we have to go around reminding people who don't deploy their apps so often to rebake their AMIs because we need to get a new base AMI that has a newer version of Java on it, for example. If we can just detect that diff exists and automatically do it for them, and it runs through their normal deployment processes and just rolls out into their environments, that saves the team that runs those change campaigns a whole lot of effort. So let's look at some concrete examples of what resolving desired state might look like. So for example, if your spec says something high level like, well, I don't know what availability zones I need to be in, I'll just be in all of them, balance me across all of the ones in the region. So you can just omit that from the spec. And this exists right now. And we'll just figure out, well, what are the availability zones in the regions you're targeting, in that VPC, in that subnet, and we'll just apply all of them. Resolving the latest version of your software is kind of one of the key things that enables us to give you the ability to roll out changes to your software without having to update that spec and resubmit it to our Keel service. So we just notice automatically that there's a new version being released and check that it's been baked, check that it has an AMI in all the right regions, and go and launch a bake task if it doesn't yet, and then get the IDs of that and plug that into the launch configuration. So you're not having to do like updates to your YAML to say, oh, I now need to deploy this new version of my package. It just automatically rolls through based on a set of rules. Some of the exciting places we'd love to get to with this capability of injecting opinions is like, well, you know, configuring cross-app ingress is hard. So wouldn't it be great if one day we could say, well, my application, in the spec, we could just say, well, my application needs to accept HTTPS traffic from this other service. And we can lean on our excellent Netflix security engineers to figure out what that means in terms of load balancers and ingress rules on security groups, and just define that for people in fine-grained detail so that it's a less error-prone process and there's less kind of failure demand on us as the centralized team who deal with people struggling with that kind of thing. And one key thing we want to stick to with managed delivery is that you can have as much or as little of this as you want. If you are a team of hardcore cloud experts who want to control every last fine-grained detail of your infrastructure, great. The capability is there. You're not required to use these abstractions and these pieces of guidance if you don't want to. But an increasing number of teams of engineers at Netflix are not that. And they would like help and guidance. And we want to support both of those extremes and everything in between as well.
All right, so we've talked about declarative infrastructure, which is the foundation of all of this. Now we'll talk about building on top of that. So the next piece that ties this together is declarative delivery. So we have two concepts we're pulling out from our experience as first-level citizens that people care about. So the first is artifacts. And that is right now the package or Docker image that you want to promote through your delivery flow. And then the next one is environments. So environments are the collection of resources that are needed to run your application. And this is exactly like you think of environments now, your test environment, your staging environment, your production environment. And this is the same example we saw earlier. And you can see from there that we have an artifact, the Debian, and then two environments, test and production. So together, those give you like a static picture of your environments and your artifact. We need something that talks about how those connect together. So the next thing is constraints. Constraints gate whether an artifact can be promoted to an environment. So for example, constraints are like, this artifact must have been deployed in a previous environment. Or this artifact can only be deployed during the workday. Or this artifact needs manual approval before it goes into an environment. And these three things, the first ones, are built or they're being built right this moment. Well, Monday this week. The second things don't exist yet, but this is where we're going. So we want to have a constraint that requires packages to be regionally rolled out, so you don't deploy globally all at once. And also we want to express things like must have been canaried or must have passed tests. And these two are specifically a good fit for the existing pipelines workflow. Pipelines are great for codifying these steps, like tests that have to be run in a certain order for calling out to Jenkins. And so we might think of these as pipelines that have run, and if they succeed, then the constraint passes, and if they fail, then the constraint doesn't pass. So let's walk through this with an example. We have our same Debian as before. We have two environments, test and production. Our test environment has 3 instances and a load balancer, and our production environment has 6 instances and a load balancer. So we express constraints. Test has no constraints. We want everything to go in. And production has 3 constraints, deployed in test, smoke tested, and canaried. When we go to check whether this artifact can be deployed into the first environment, we see yes, because there's no constraints. So we'll go ahead and deploy that for you. When we're checking the next environment, we see that, yes, it has been deployed in test, but it hasn't passed these other constraints. So it doesn't qualify to be deployed into production, but we can take action to make sure that those constraints will eventually be satisfied, like running the tests and canarying with the proper configuration. So here is a sample declarative delivery config. This is much shortened to fit on the slide, but we'll go through some key examples. So we have a name of the configuration, an application that it relates to, and a list of artifacts. We have a sample Debian here. And then we have a list of environments. You'll notice this also has a test and prod environment. There are 0 constraints on the test environment, and there are 2 resource definitions. All of the details have been omitted here, but this is the same resource definition that you saw before. And we're grouping this load balancer and cluster together to make the test environment. Same for prod. We have 2 resources. They make up the production environment, and then it has 1 constraint here represented, which is that it depends on the test environment. And this is also real and working. So let's talk more in detail about how an artifact gets promoted and how we think about that. So here, for example, we have 5 artifacts. They're Debians, and they're named using semantic versioning. So we can figure out which is the latest in those. And for each artifact, each environment, we want to find the latest artifact that's qualified to be deployed. A quick note, when I say latest here, I really mean for the flow you're thinking about, what is the most recent piece of code that's been built? You can denote that in several ways. But here we're just thinking about this like the package has been built for master and it's using an increasing version, so we can tell. But this is flexible. So every time we need to figure out which artifact should be in an environment, we pass through this loop. So we have 3 constraints here. It doesn't really matter what they are, but if you'd like to think about an example, you can think of the same ones for our production environment earlier, which is deployed into a previous environment, tested, smoke tested, and canaried. So we can see that our most recent artifact, the latest version, doesn't meet the constraints. So we step back to the previous one. We can see here that that meets 2 of the constraints, but not all 3. That doesn't qualify to be deployed into our environment. We look back 1 more version that has met all the constraints, and it's the one we want. We don't need to look any further. One thing to note is that this is just for how we evaluate whether the artifact should be in the environment. Keel will be taking action to make sure that the other artifacts meet the constraints in a separate area. This means that you don't have to commit, as Rob said, you don't have to commit your latest version to your YAML and push that to us. If you'd like, we'll figure that out for you. All right, what does this look like?
So right now we have some basic support in the deck component, Spinnaker's UI. So you can see a managed delivery logo on some of those resources on these clusters here. And the logo is a little bit specialized to show you that the resource at the top there, the pre-staging environment, is taking some kind of action. There's a little cog or something there that shows it's in transition to its desired state. And you can also see that there's a task running. When you look at the tasks view, any action that Keel takes is done via Orca right now. So you can always see the things that are going on, but just by looking at the tasks view that exists already. And what we really want to avoid is this scenario where people are like, oh, what the hell is going on? There are random tasks happening everywhere. Why is this thing deploying? Why is it not deploying when I expected it to? So we want to be really transparent about the fact Keel is taking action, why it's taking that action, what it's doing, why it's maybe not doing something yet. And we have a lot of new UI components that will help you visualize the flow of artifacts through those environments. But we're already leaning on some of the existing UI components just to, nothing's going to be hidden away from the user. We do have some new kind of informational stuff. So we have the little managed delivery logo there on any resource that's being managed. And you can look at the history. Right now, that history is in exciting raw JSON format, but some UI will be coming pretty soon. But we can see useful things like it's a stream of events that have happened or been detected happening to that resource. So for example, the most recent event there is we've launched an actuation, which is an attempt to resolve desired against current state. And we have an ID of a task in Orca that was launched in order to do that and a description of what it was trying to do. And the event prior to that is details of the delta we detected. So this is really nice because we can see, the reason we're doing this is because there was a change in the desired application version that should be on that cluster. So we detected that you released a new version of software that passed the constraints to get into that environment if there are any, and that was now the new resolved desired state, and therefore we need to do a deployment. If all else fails, we want people to be able to turn management off. If you're in the middle of an incident and you want to be utterly in control, you want to turn off autopilot and take the yoke of the plane, we have the ability to do that. So if you go into the application configuration, there's just a big friendly button that says pause management. You press that and Keel stops even looking at your application until you press it again to turn it off. So that enables people to just take that control when they need to if there is a break the glass situation. So a lot of that UI is still in progress or coming. Is this production ready? Well, not quite yet, but it's getting there. Things we're actively working on right now are more constraints. The next most obvious one to build, I think, is manual approval. That's like the ultimate easiest way to control things getting into a production environment. We'd like to build that staggered regional rollout because many of our teams at Netflix are relying on that strategy. They don't want to deploy into certain regions during traffic peaks. They want to do it in traffic dips. And they don't want to deploy everything into all the regions at once in case there's a problem. If there's a problem, they'd rather just impact one region that they can potentially evacuate. We'd like to build that UI for environments and the history of resources. And we'd like to stabilize our resource schemas. Right now, we're kind of trying very hard to model this very, very well, those specification schemas for resources, trying to model those in a type-safe way so that we can generate validation tools for people. And right now, we're still tweaking that, and we'd like to be able to get that pinned down before we really say it's production ready. And we'd like a bit better Git integration story. Right now, we're using Spinnaker's Git trigger to track changes to delivery configurations or resource definitions, and then run a little task that will submit that to Keel. That could be a little tighter, but it works. So if you're intrigued, please come join the Spinnaker as CodeSig. Please ask us questions, offer suggestions. We'd love help with any other clouds that that Netflix is not using. Particularly Kubernetes would be really interesting, where you could eliminate a lot of that kind of infrastructure as code part because you don't need that, but you could build the delivery side of things on top of it potentially. If you've got a suggestion for the name for that thick buff unicorn on the first slide, then get in touch. If you have any questions, if we have time, we're happy to take a few now. Otherwise, we have a breakout in the room Satisfaction, which I believe is downstairs. And we also have a Slack channel in the open source Slack if you'd like to talk to us. So,
thanks for listening.